What if I told you that right now, as you're watching this video, photons of light are racing through your body at 299,792,458 meters per second, and there's absolutely nothing you or anyone else can do to slow them down or speed them up, not even by a single meter per second? Here's what will blow your mind. Every single photon that has ever existed, from the first light of the Big Bang 13.8 billion years ago to the light hitting your eyes right now, travels at exactly the same speed. Not approximately the same, not roughly the same, exactly the same speed, always. Think about that for a moment. We can slow down hurricanes with cloud seeding. We can speed up chemical reactions with catalysts. We can even slow down time itself with extreme gravity. But light laughs at our attempts to control it. It's the one thing in our universe that follows an absolute, unchangeable rule. But here's the revelation that's going to shatter everything you think you know about reality. Light doesn't actually travel at the speed of light. The universe has a fundamental speed limit built into the fabric of space and time itself, and light just happens to be the messenger that revealed this cosmic law to us. By the end of this journey, you're going to understand why this seemingly simple fact about light speed is actually the key to unlocking the deepest mysteries of our universe, from why time travel might be impossible to why you exist at all. Before we dive into this mind-bending exploration, smash that like button if you're ready to have your understanding of reality completely transformed. And I'm genuinely curious, drop a comment telling me what country you're watching from and what time it is where you are. I want to see this global community of curious minds in action. Don't forget to subscribe, because we're about to embark on the most important physics lesson of your life. You flip a light switch, and instantly, your room fills with light. Common sense tells us light is just ... fast. Really, really fast. Like a cosmic speed demon that races from your light bulb to your eyes in what feels like no time at all. But here's your first mind-blown moment. Light from that bulb doesn't actually reach you instantly. It takes time. Not much time, we're talking about billionths of a second, but it takes time. And that tiny delay is about to reveal one of the universe's most profound secrets. Think of it like this. Imagine you're in a massive concert hall, and someone at the very back shouts your name. The sound travels to you at about 343 meters per second. You can actually experience the delay. Now imagine that same person flashes a laser pointer at you. The light travels at 299,792,458 meters per second, nearly 1,000,000 times faster than sound. The delay is so small you can't perceive it, but it's there. This is where our story really begins, because in 1676, a Danish astronomer named Ole Rachmer made an observation that would eventually unlock the secrets of the universe. He was studying Jupiter's moons, and he noticed something weird. The moons appeared to speed up and slow down in their orbits, depending on where Earth was in its orbit around the Sun. But the moons weren't actually changing speed. Rachmer realized that light itself had a finite speed, and when Earth was farther from Jupiter, the light simply had more distance to travel. This was the first time in human history that someone proved light wasn't instantaneous. Here's what's fascinating. Rachmer calculated light speed at about 220,000 kilometers per second. Not perfect, but remarkably close for 1676. He had discovered something fundamental about our universe using nothing but careful observation and brilliant reasoning. Now, here's where things get interesting. For the next 200 years, scientists assumed light was like sound a wave that needed something to travel through. They called this mysterious substance the luminiferous ether. Think of it like an invisible ocean filling all of space. And light waves were like ripples moving through this cosmic sea. This seemed logical. After all, ocean waves need water, sound waves need air, so surely light waves needed ... something, right? But in 1887, Two American scientists, Albert Michelson and Edward Morley, conducted what many consider the most important failed experiment in history. They tried to detect Earth's motion through this supposed ether. If we're moving through an invisible medium, they reasoned, light should travel faster when moving with our motion and slower when moving against it. Here's the mind-blowing result. No matter which direction they measured, no matter how Earth was moving, light always traveled at exactly the same speed. The ether didn't exist. Light didn't need a medium. It just traveled through empty space at a constant speed. This result was so shocking that scientists spent years trying to explain it away. But the evidence was undeniable. Light had revealed its first secret. It plays by different rules than everything else we know. And that's when a young patent clerk in Switzerland realized that this failed experiment had actually revealed the most profound truth about our universe. What if I told you that in 1905, a 26-year-old patent examiner named Albert Einstein looked at the Michelson-Morley results and said, "What if everyone's been asking the wrong question?" While other scientists were trying to explain why light always traveled at the same speed despite Earth's motion, Einstein asked, "What if that's just how the universe works? What if the speed of light is constant, not because of some property of light, but because of some fundamental property of space and time themselves?" This single question would revolutionize our understanding of reality. Einstein's breakthrough came from accepting two seemingly contradictory ideas as both being true. First, the laws of physics are the same for everyone moving at constant speeds. This seems obvious if you're in a smoothly moving car. Physics works exactly the same as when you're standing still. Second, light travels at the same speed for everyone, regardless of how they're moving. This seems impossible, but the Michelson-Morley experiment proved it was true. Think of it like this. Imagine you're on a train traveling at 100 kilometers per hour, and you throw a ball forward at 50 kilometers per hour relative to the train. Someone standing on the platform would see that ball moving at 150 kilometers per hour, the train's speed plus the ball's speed. This is basic addition, and it works for everything we experience in daily life. But light doesn't work this way. If you're on that same train and shine a flashlight forward, both you and the person on the platform measure the light traveling at exactly 299,792,458 meters per second. Not 299,792,458 plus the train speed. Just 299,792,458 meters per second. This should be impossible. But Einstein realized that if this is true and experiments proved it, was then our assumptions about space and time must be wrong. Here's your second mind-blown moment. Einstein figured out that space and time aren't separate, fixed things. They're connected into what he called space-time, and this space-time can stretch and compress to keep light's speed constant for everyone. When you move really fast, time literally slows down for you, and space contracts in the direction you're moving. This isn't just theoretical, it's measurable. GPS satellites have to account for this time dilation, or your phone's navigation would be off by miles. But here's the truly revolutionary insight. Light doesn't travel at the speed of light because it's light. Light travels at this speed because it has no mass. And anything with no mass must travel at what physicists call chi, the fundamental speed limit of the universe. Think of space-time like a cosmic speed limit sign. It doesn't say maximum speed for light, 299,792,458 meters per second. It says universal speed limit, 299,792,458 meters per second. Anything with zero mass must travel at this speed. No exceptions. This is why light can't be sped up or slowed down. It's not a property of light. It's a property of reality itself. But wait, you might be thinking, I can slow light down. I can shine a flashlight through water or glass, and light travels slower there. Here's where it gets even more mind-bending. Light isn't actually slowing down when it passes through materials. Individual photons are still traveling at exactly c. What's happening is that light gets absorbed and re-emitted by atoms in the material, creating a delay that makes it appear slower on average. But each photon, in the brief moments it exists between interactions, is still traveling at the same unchangeable speed. This led Einstein to one of the most famous equations in history, E equals mc. This equation reveals that mass and energy are two forms of the same thing, and the conversion factor between them is c squared, the speed of light squared. But here's what's really going to blow your mind. This equation explains why nothing with mass can reach the speed of light. As you approach light speed, your mass effectively increases toward infinity, requiring infinite energy to accelerate further. The universe has built-in protection against breaking its own speed limit. The implications are staggering. Time travel to the past becomes problematic because information can't travel faster than light. Cause and effect are preserved because nothing can outrun light to deliver a message to its own past. Einstein had discovered that light's constant speed isn't just a quirky property of electromagnetic radiation. It's the cosmic speed limit that governs every interaction in the universe, from the tiniest quantum particle to the largest black hole. But we're just getting started. Because when Einstein applied these ideas to gravity, he discovered something even more shocking about the nature of space and time. Here's what will absolutely shatter your understanding of reality. Gravity isn't a force pulling things together. Gravity is the shape of space-time itself. In 1915, 10 years after his special relativity breakthrough, Einstein realized that his theory was incomplete. Special relativity worked perfectly for objects moving at constant speeds, but what about acceleration and gravity? Einstein's genius insight came from what he called his happiest thought. Picture this. You're in a windowless elevator in deep space. Someone starts accelerating the elevator upward at exactly 9.8 meters per second squared, the same acceleration as Earth's gravity. Einstein realized you would have no way to tell whether you're in an accelerating elevator in space or standing still in Earth's gravitational field. This led to a mind-blowing conclusion. Acceleration and gravity are the same phenomenon. But if that's true, and we know acceleration can affect time and space, then gravity must also affect time and space. Think of it like this. Imagine space-time as a stretched rubber sheet. Place a bowling ball in the center. It creates a dip. Now roll a marble nearby. The marble doesn't feel a force pulling it toward the bowling ball. It's simply following the straightest possible path through curved space, which happens to curve around the bowling ball. This is gravity. Massive objects bend space-time, and everything else, including light, follows the curves. But here's your third mind-blown moment. If space-time itself is curved by mass, then light, which always travels in straight lines through space-time, should follow those curves. In other words, gravity should bend light. This prediction seemed impossible. Light has no mass. How could gravity affect something with no mass? But Einstein's mathematics were clear. Light would bend around massive objects, not because gravity pulls on the light, but because the light is traveling in a straight line through curved spacetime. In 1919, during a total solar eclipse, British astronomer Arthur Eddington set out to test this prediction. He measured the positions of stars that appeared near the sun during the eclipse. According to Einstein's theory, the sun's massive gravitational field should bend spacetime enough to make these stars appear slightly displaced from their normal positions. The results were exactly what Einstein predicted. Light from distant stars was indeed bending around the sun. Spacetime was curved, just as the equation suggested. This experiment made Einstein instantly famous worldwide. But more importantly, it revealed something profound about light's relationship to the universe. Light doesn't just reveal the cosmic speed limit, It's also our best tool for mapping the shape of spacetime itself. But here's where things get really weird. If massive objects bend spacetime, what happens when an object is so massive that it bends spacetime completely closed? What happens when the curvature becomes so extreme that even light can't escape? You get a black hole, a region where spacetime is so curved that the path light must follow loops back on itself. The light isn't slowed down or stopped in the traditional sense. It's still traveling at exactly c, but through spacetime so warped that forward leads back to where it started. Think of it like being on a treadmill, moving backward at the same speed you're walking forward. You're walking at your normal speed, but you're not getting anywhere. Light inside a black hole's event horizon is doing exactly this, traveling at c, through spacetime that's moving backward at c. This reveals something profound. Even in the most extreme conditions in the universe, light maintains its speed. Black holes don't slow light down. They reshape reality so completely that light's straight-line path becomes a prison. But here's what's truly mind-bending. From light's perspective, it's always traveling in a straight line at the same speed. It's the universe itself that's doing the bending. This realization led Einstein to an even more startling conclusion about the nature of time itself. In regions of strong gravity, time runs slower. This isn't just theory, it's measurable. Time moves slower at sea level than on a mountaintop because Earth's gravity is slightly stronger at sea level. GPS satellites must account for this effect. Because they orbit high above Earth where gravity is weaker, their clocks run faster than clocks on the surface. Without correcting for this time difference, GPS would become useless within hours. But here's the really mind-bending part. Light always measures the same speed regardless of these time differences. In strong gravity where time runs slower, distances contract proportionally, so light still travels at exactly c as measured locally. The universe conspires to keep light's speed constant even as it warps space and time around massive objects. This raises a profound question. If light's speed is so fundamental that the universe reshapes reality itself to preserve it, what does this tell us about the nature of existence? The answer is about to challenge everything you think you know about time, space, and your place in the universe. What if I told you that at the quantum level, light doesn't just travel at a constant speed, it creates the very fabric of reality through its interactions? We've explored how light behaves in the large-scale universe of Einstein's relativity. But when we zoom down to the quantum world, light reveals even more mind-bending secrets about why its speed can't be changed. Here's your fourth mind-blown moment. Light isn't just electromagnetic radiation traveling through space. Light is the fundamental messenger particle that carries the electromagnetic force, one of the four fundamental forces that govern all interactions in the universe. When you touch something, you're not actually making contact. What you perceive as touching is the electromagnetic force between the electrons in your hand and the electrons in the object. This force is mediated by virtual photons, light particles that exist for incredibly brief moments to carry information about the electromagnetic interaction. These virtual photons must travel at exactly c, not because they choose to, but because that's the only speed at which massless force-carrying particles can exist. The speed of light isn't just light speed, it's the speed of electromagnetic information itself. But here's where quantum mechanics gets really weird. In 1900, Max Planck discovered that light comes in discrete packets of energy called quanta, later named photons, by Einstein in 1905. Light isn't a continuous wave, it's made of individual particles of electromagnetic energy. Each photon carries a specific amount of energy determined by its frequency. E equals hf, where h is Planck's constant and f is frequency. Higher frequency light, like blue light, carries more energy per photon than lower frequency light, like red light. But here's the kicker regardless of their energy. LL photons travel at exactly the same speed. Think of it like this. Imagine cars on a highway where every vehicle, whether it's a motorcycle or a massive truck, must travel at exactly 65 miles per hour. The trucks carry more cargo, energy, than the motorcycles, but they all move at the same speed. That's how photons work: different energies, identical speeds. This leads to a profound realization about why light's speed can't be changed. In quantum field theory, developed by physicists like Richard Feynman in the 1940s, particles are excitations in underlying quantum fields. The photon is an excitation in the electromagnetic field, and the properties of this field, including the speed at which excitations propagate, are built into the fundamental structure of spacetime. Here's what's truly mind-blowing. The speed of light emerges from two fundamental constants of nature: the permeability and permittivity of free space. These aren't arbitrary values. They describe how electric and magnetic fields interact with the vacuum of space itself. Light's speed is literally determined by the electromagnetic properties of empty space. Maxwell figured this out in the 1860s when he derived his famous equations describing electromagnetic fields. When he solved these equations for waves propagating through empty space, out popped the speed of light, not put in by hand, but emerging naturally from the mathematics of electromagnetic fields. But quantum mechanics adds another layer of weirdness. According to the Heisenberg uncertainty principle, you can't simultaneously know both the exact position and momentum of a quantum particle. This applies to photons too, but with a twist. Since photons always travel at speed c, their momentum is completely determined by their energy, P equals EC. This means there's a fundamental uncertainty in where a photon is and what energy it carries. This uncertainty isn't a limitation of our measurement tools. It's a fundamental property of reality, and it's intimately connected to light's constant speed. The universe maintains light speed by distributing uncertainty between other properties. Here's another mind-bending aspect. In quantum electrodynamics, QED, the theory that describes how light and matter interact, photons are constantly being created and destroyed in the quantum vacuum. Even empty space is filled with virtual photons, popping in and out of existence. These virtual photons also travel at speed c during their brief existence, contributing to the electromagnetic properties of the vacuum that determine light speed. This creates a beautiful circular logic. Light speed helps determine the properties of empty space, and the properties of empty space determine light speed. It's a self-consistent loop that locks light speed into the fundamental structure of reality. But here's what's really going to blow your mind. This quantum understanding of light reveals why faster-than-light communication is impossible, even in principle. Information is always carried by particles or fields, and all information-carrying interactions are ultimately limited by the speed at which quantum fields can propagate. Disturbances, which is always c or less. Even quantum entanglement, where particles seem to instantly affect each other across vast distances, doesn't actually transmit information faster than light. The correlations are instantaneous, but you can't use them to send messages faster than c. This raises a profound question. If light speed is so fundamental to quantum mechanics, and quantum mechanics describes the behavior of everything in the universe, then what role does light speed play in determining what kinds of universes are possible? The answer involves some of the most cutting-edge ideas in modern physics, and it's going to change how you think about why you exist. Here's what will completely reshape your understanding of your place in the cosmos. The speed of light isn't just a constant, it's perfectly tuned to allow complex structures like atoms, stars, and ultimately you to exist. What if I told you that if light traveled even slightly faster or slower, you wouldn't be here to watch this video? This brings us to one of the most mind-bending concepts in modern physics, the anthropic principle. It's the idea that the fundamental constants of nature, including the speed of light, seem to be precisely calibrated to allow for the existence of observers like us. Let's explore why light's exact speed is crucial for existence itself. First, consider atoms. The electromagnetic force that holds electrons in orbit around atomic nuclei is transmitted by photons traveling at speed c. If light were slower, electromagnetic interactions would be weaker, making atoms less stable. If light were faster, electromagnetic interactions would be stronger, potentially making atoms too tightly bound to participate in chemistry. But here's your fifth mind-blown moment. The relationship between light speed and other fundamental constants determines the fine structure constant, a dimensionless number, approximately equal to 1/137th, that governs the strength of electromagnetic interactions. This number, discovered by Arnold Sommerfeld in 1916, determines how tightly electrons bind to atomic nuclei. If it were significantly different, which would happen if light speed were different atoms, as we know them couldn't exist. Think of it like this. Imagine the universe as a cosmic recipe, and the fine structure constant is like the ratio of ingredients. Too much flour, and you get a brick. Too little, and you get soup. The fine structure constant has to be just right for atoms to be stable enough to form complex molecules, but loose enough to engage in chemistry. Richard Feynman called the fine structure constant one of the greatest damn mysteries of physics, because it seems to be precisely tuned for complexity. And light speed is a key ingredient in determining this crucial value. But the implications go much deeper. Stars, the cosmic furnaces that forge the heavy elements necessary for life, depend critically on light speed for their stability. Inside a star, gravity tries to collapse the star, while radiation pressure from light tries to blow it apart. This creates a delicate balance called hydrostatic equilibrium. The radiation pressure depends on photons traveling at exactly speed c to carry energy from the star's core to its surface. If light were slower, radiation pressure would be weaker, and stars would collapse more easily, burning through their fuel faster and living shorter lives. If light were faster, radiation pressure might be too strong, preventing stars from maintaining stable nuclear fusion. But here's what's truly mind-bending. The speed of light also determines the rate at which stars can cool by radiation. This affects stellar lifetimes, which affects how long planets have to develop complex chemistry and potentially life. Our sun has been burning steadily for about 4.6 billion years, providing a stable energy source for Earth's development. This stellar stability depends on the precise value of light speed, maintaining the right balance between gravitational collapse and radiation pressure. Here's another layer of anthropic fine-tuning. Light speed determines how electromagnetic radiation propagates through space, which affects how energy from stars reaches planets. If light were much slower, the inverse square law for radiation would work differently, potentially making planetary surfaces either too hot or too cold for liquid water. The speed of light also affects the formation of cosmic structures. In the early universe, light's ability to travel at exactly speed c determined how radiation and matter interacted during cosmic inflation in the formation of the first atoms. This process, called recombination, happened when the universe became transparent to light for the first time. If light's speed were different, this transition might have happened at a different time or temperature, potentially preventing the formation of the cosmic web of matter that eventually led to galaxies, stars, and planets. But here's the most mind-blowing aspect. Some physicists argue that the anthropic principle suggests we live in a multiverse, an infinite collection of universes with different values for fundamental constants, like the speed of light. In this scenario, most universes would have speeds of light that don't allow for complex structures or observers. We observe a universe with the right speed of light, not because it's special, but because we can only exist in universes where the constants allow for observers. Think of it like this. Imagine throwing billions of darts at a dartboard in a dark room. Most darts miss the bullseye, but you only notice the ones that hit. Similarly, in an infinite multiverse, most universes are misses with constants that don't allow life, but we only observe the hits where life is possible. This idea is controversial because it's difficult to test, but it highlights just how precisely tuned light's speed appears to be for the existence of complexity and consciousness. But here's what's really going to challenge your worldview. If light's speed is so fundamental to existence, what does this tell us about the nature of time, space, and consciousness itself? The answer leads us to some of the most profound questions in science and philosophy. What if I told you that time itself might not exist the way you think it does, and that light's constant speed is actually revealing the deepest truth about the nature of reality? We've explored how light's speed affects the physical universe, but now we're going to dive into how it fundamentally shapes our experience of time, causality, and existence itself. Here's your sixth mind-blown moment. From a photon's perspective, time doesn't exist. A photon created in the core of the sun and a photon created at the edge of the observable universe both experience the same amount of time during their journey, which is none at all. This seems impossible, but it's a direct consequence of Einstein's relativity. As you approach the speed of light, time dilation becomes extreme. At exactly the speed of light, time stops completely. Every photon exists in a timeless state, experiencing its entire journey from creation to absorption as a single, instantaneous event. Think of it like this. Imagine you're watching a movie, but someone keeps slowing down the playback speed. As you approach light speed, the movie gets slower and slower until, at light speed, it freezes completely. From the photon's perspective, the universe is a single frozen moment. This raises a profound question. What is time, really? Einstein realized that time isn't a universal constant ticking away independent of everything else. Time is intimately connected to space and motion. The speed of light isn't just the speed limit of the universe, it's the exchange rate between time and space. Here's what's mind-bending. Light's constant speed in space-time is what creates our subjective experience of time's passage. When we measure light always traveling at the same speed despite our motion, what we're actually measuring is how space-time itself adjusts to preserve this constant. But this leads to an even more startling realization. Simultaneity, the idea that events can happen at the same time, is an illusion. Consider this thought experiment. You're on a train and you see lightning strike the front and back of the train at the same moment. But someone standing on the platform sees the front lightning strike first, then the back. Who's right? Einstein's answer: both observers are equally right. There is no absolute same time. Simultaneity depends on your reference frame, and light's constant speed is what makes this true. This demolishes our intuitive understanding of causality. We assume cause must precede effect, but in Einstein's universe, the order of events can depend on who's observing them as long as the events are separated by distances that light can't travel between them in the time interval. Here's the really mind-bending part. This means that now is fundamentally meaningless for distant events. When you look at a star 100 light years away, you're seeing it as it was 100 years ago. But what's happening there, right now? The question has no answer, because right now depends on your reference frame. Light's constant speed creates what physicists call the relativity of simultaneity, which suggests that the entire history of the universe, past, present, and future, might exist simultaneously in what's called the block universe. From this perspective, time doesn't flow like a river. Instead, all moments exist equally in four-dimensional spacetime, and our consciousness simply experiences different slices of this eternal block as we move through it. But here's where things get really weird. If this block universe view is correct, then light's journey from any point to any other point already exists as a complete path through spacetime. Photons aren't traveling through time. They're revealing the structure of spacetime itself. This connects to some cutting-edge ideas in modern physics. Some physicists propose that time might be an emergent property, something that arises from more fundamental processes rather than being fundamental itself. In this view, Light's speed might not be a speed limit in the traditional sense. Instead, 100 might be a fundamental unit of space-time geometry, the conversion factor between spatial and temporal dimensions of reality. Think of it like this. Imagine a map where 1 inch represents 1 mile. The speed of 1 inch per mile isn't really a speed, it's the scale of the map itself. Similarly, c might be the fundamental scale that relates space to time, and what we call light speed is just how this scale manifests in our experience. This has profound implications for our understanding of consciousness and free will. If all moments exist equally in the block universe, and light's constant speed reveals this eternal structure, then our sense of time's passage might be a fundamental limitation of consciousness rather than a property of reality. But here's what's truly mind-blowing. Recent experiments in quantum mechanics suggest that the relationship between time and consciousness might be even stranger than Einstein imagined. What if I told you that light's interaction with conscious observers might literally create the reality we experience, and that the speed of light determines how quickly reality becomes real? We're now entering one of the most controversial and mind-bending areas of modern physics, the quantum measurement problem and its relationship to consciousness. Here's the setup. In quantum mechanics, particles don't have definite properties until they're measured. Before measurement, an electron can be in multiple locations simultaneously. A photon can travel multiple paths at once, and quantum systems exist in superposition, a combination of all possible states. But here's your 7th mind-blown moment. When we measure a quantum system, it instantly collapses into a single definite state. And this collapse happens instantaneously, regardless of how spread out the quantum system was. This seems to violate Einstein's rule that nothing can happen faster than light. This paradox tormented Einstein, who called quantum entanglement spooky action at a distance. How could quantum measurements have instantaneous effects when nothing should be able to travel or communicate faster than light? The answer reveals something profound about light's role in the measurement process itself. When you observe a quantum particle, you're actually interacting with it using photons. You can't see an electron directly. You see light that has bounced off the electron or been emitted by it. Every quantum measurement involves photons traveling at speed c, carrying information from the quantum system to the measuring device. Here's what's mind-bending. The instantaneous collapse isn't actually instantaneous. It's limited by the speed of light, the speed at which information can travel from the quantum system to the observer. But this raises an even deeper question. What constitutes an observer? Does it have to be a conscious human? Or can any measuring device collapse the wave function? This is where things get really weird. Some interpretations of quantum mechanics, like the consciousness causes collapse interpretation proposed by physicists like Eugene Wigner, suggest that consciousness itself plays a fundamental role in determining reality. In this view, light doesn't just carry information about reality. It carries information that helps create reality through the measurement process. And the speed of light determines how quickly this reality creation process can occur. Think of it like this. Imagine reality is like a giant quantum computer, constantly calculating all possible outcomes of every quantum interaction. Light, traveling at speed c, carries the results of these calculations from quantum systems to observers, collapsing infinite possibilities into definite outcomes. But here's where it gets even stranger. Recent experiments have confirmed that quantum entanglement is real, but it can't be used to send information faster than light. When you measure one entangled particle, you instantly know something about its partner, but you can't use this to send a message to someone measuring the partner particle. This suggests that quantum mechanics preserves causality by allowing instant correlations, but preventing faster-than-light information transfer. Light's speed limit isn't violated because no information actually travels faster than c. But some physicists push this even further. In the many worlds interpretation of quantum mechanics, every quantum measurement splits reality into multiple parallel universes. In this view, light doesn't just carry information, it helps navigate between parallel realities. Each time a photon interacts with matter, it creates a branching point where reality splits into all possible outcomes. Light's speed determines how quickly these reality branches propagate through space-time. Here's another mind-blowing possibility. Some theories suggest that consciousness itself might be a quantum process, and that our subjective experience of time might be related to the rate at which our brains process quantum information carried by photons. In this view, the speed of light doesn't just limit physical processes, it limits the speed of thought itself. Our consciousness experiences reality at the rate that photons can carry information between neurons in our brains. But here's what's really going to challenge everything you think you know. If light's speed determines how quickly reality becomes real through quantum measurements, and if consciousness plays a role in this process, then the speed of light might literally determine the rate at which you create your experienced reality. This connects to some of the most cutting-edge ideas in modern physics and neuroscience. Some researchers propose that consciousness might be a fundamental property of the universe, not something that emerges from complex matter. In this panpsychist view, every interaction between particles, including every interaction involving photons, has a rudimentary conscious aspect. Light doesn't just carry information, it carries experience itself through the cosmos at speed c. If this sounds far-fetched, consider this. We still don't understand how subjective experience arises from objective physical processes. The hard problem of consciousness remains unsolved. Maybe consciousness and light speed are more intimately connected than we've ever imagined. But even if consciousness doesn't directly affect quantum measurements, light speed still plays a crucial role in how we experience reality. The finite speed of light means that everything you see, every photon hitting your eyes, carries information about the past. You never experience the present moment. You always experience the universe as it was, delayed by the time it takes light to reach you. This brings us to a profound realization about the nature of experience itself. Here's what's going to completely change how you experience your daily life. Every single thing you've ever seen, every color you've ever experienced, every face you've ever recognized, all of it came to you at exactly 299,792,458 meters per second. Not approximately. Exactly. Let me make this personal for you. Right now, as you're watching this video, photons are streaming from your screen into your eyes at light speed. But here's your eighth mind-blown moment. You're not seeing now. You're seeing the past, even if it's just billionths of a second ago. Every moment of your visual experience is a historical record carried by light. When you look at your hand, you're seeing it as it was nanoseconds ago. When you look at the moon, you're seeing it as it was 1.3 seconds ago. When you look at the sun, you're seeing it as it was 8 minutes and 20 seconds ago. But here's what makes this personally profound. Your entire visual experience of reality is constructed from light that has traveled to you at this one unchangeable speed. Every memory you have that involves sight, every emotion triggered by seeing something beautiful, every moment of recognition when you see someone you love, all of these experiences were delivered to your consciousness by photons traveling at exactly c. Think about that for a moment. The light carrying your mother's smile to your eyes travels at the same speed as the light from the most distant galaxy. The photons that let you see these words are moving at exactly the same speed as the cosmic background radiation left over. From the Big Bang, you are connected to the entire universe through this one fundamental constant. Here's what's deeply moving about this. Light doesn't discriminate. It doesn't travel faster for more important information or slower for mundane details. The light carrying news of a birth travels at the same speed as light carrying news of a death. The light revealing scientific breakthroughs travels at the same speed as light from your morning coffee. This creates a profound equality in the universe. Every piece of visual information, from the grandest cosmic event to the smallest personal moment, arrives at your consciousness carried by photons obeying the exact same universal speed limit. But here's where it gets emotionally powerful. Because light speed is finite, you literally live in the past. But so does everyone else. When two people look at each other, they're both seeing the other person as they were nanoseconds ago. Every conversation, every shared glance, every moment of human connection happens across this tiny but real-time gap created by light's finite speed. This means that true simultaneity, experiencing something at exactly the same moment as someone else, is impossible. Even when you and a friend both see the same lightning strike, you each see it at slightly different times depending on your exact positions. You each live in your own slightly different version of now, connected but forever separated by the finite speed of light. Here's something that might change how you think about memory. Every visual memory you have is encoded with information that traveled to you at light speed. The light patterns that formed your memory of your first day of school, your wedding, your child's first steps, all of these experiences were delivered to your brain by photons traveling at sea. In a very real sense, your visual memories are fossils of ancient light. The photons that created these memories have long since been absorbed, but the information they carried shaped your neural networks and became part of who you are. But here's what's truly beautiful. Light's constant speed means that everyone in the universe shares this same fundamental experience. An alien observer on a planet around Proxima Centauri, 4.2 light years away, experiences their universe through light traveling at exactly the same speed as the light in your living room. This creates a cosmic fellowship of observers, all connected by this universal constant. No matter how different alien life might be from us, if they experience reality through electromagnetic radiation, they encounter the same unchangeable speed limit that governs your daily experience. Here's another profound personal connection. The atoms in your body were forged inside stars billions of years ago. The carbon in your muscles, the calcium in your bones, the iron in your blood, all of these elements were created in stellar furnaces and distributed throughout space when those stars died. But here's what's amazing. The information about these stellar processes, the light that revealed how stars work and how heavy elements are created, traveled to Earth at exactly the same speed as the light now reflecting off your skin. You are literally made of stellar material, and the light that taught us this fact travels at the same speed as the light by which you see yourself. This connects you to cosmic history in a very tangible way. The light by which you see your reflection has the same fundamental properties as the light that has been traveling through space for billions of years, carrying information about the formation of galaxies, the birth and death of stars, and the evolution of the cosmos. But here's what might be the most personally meaningful aspect. Because light speed is constant and finite, every photograph you've ever taken or been in represents a specific moment in space-time that can never be repeated. The light patterns captured in that photo, whether on film or in digital pixels, preserve information that traveled to the camera at exactly C from that unique configuration of matter and energy. When you look at old photographs, you're seeing light that was traveling at the same speed then as it is now, but from arrangements of atoms and molecules that no longer exist in exactly that configuration. Every photo is a record of light speed's role in preserving moments in spacetime. This raises a beautiful question about the nature of existence. If your entire visual experience of reality comes from light traveling at this one unchangeable speed, what does this tell you about your place in the universe? The answer is both humbling and empowering. What if I told you that light's unchangeable speed isn't just a physical law? It's a window into the deepest nature of existence itself, revealing truths about reality that philosophers have pondered for thousands of years. We've explored the science, but now let's dive into what light speed tells us about the fundamental nature of being, knowledge, and our place in the cosmos. Here's your ninth mind-blown moment. The fact that light speed is the same for all observers means that the universe has an objective structure, independent of any individual perspective. Yet paradoxically, this objectivity can only be accessed through subjective observation. Think about this paradox. Einstein's relativity shows us that space and time are relative. They depend on the observer's motion. There's no absolute rest frame, no universal now, no objective simultaneity. Yet the speed of light is absolute. It's the same for everyone. This reveals something profound about the nature of reality itself. The universe seems to be constructed in such a way that subjective experiences, like measurements of space and time, are relative. But certain fundamental relationships, like the speed of light, remain absolute. This connects to ancient philosophical questions about the nature of truth and reality. Plato argued that behind the changing world of appearances, there must be eternal, unchanging forms. Light speed is remarkably similar to a Platonic form and eternal, unchanging principle that manifests identically regardless of perspective. But here's what's philosophically revolutionary. Light speed suggests that the universe is neither purely objective, existing, independent of observers, nor purely subjective, existing only in consciousness. Instead, it's what philosophers call intersubjective. Its structure emerges from the relationships between observers and the observed. Consider this. You can never measure your own motion absolutely. You can only measure your motion relative to something else. But light always measures the same speed relative to you, no matter how you're moving. This means that light speed is the universe's way of providing an absolute reference within a relative reality. Here's what's deeply meaningful about this. It suggests that the universe has a kind of built-in fairness principle. No observer is privileged over any other. Everyone gets the same fundamental constants, the same physical laws, the same speed of light. The universe doesn't play favorites. This has profound implications for how we think about consciousness and free will. If the speed of light is truly constant for all observers, including artificial intelligence, alien life, or any possible form of consciousness, then there's something universal about the nature of observation itself. But here's where it gets even more mind-bending. Light speed might be telling us something fundamental about the nature of information itself. In physics, information can never be created or destroyed. It can only be rearranged. And information can never travel faster than light. This suggests that light speed isn't just the speed of electromagnetic radiation. It's the maximum speed at which reality can be updated. It's the universe's processing speed, the rate at which cause and effect can propagate through space-time. From this perspective, you're not just an observer of reality. You're part of the universe's information processing system. Every observation you make, every decision you choose, every thought you think contributes to the ongoing computation of reality itself. And all of this happens at rates limited by the speed of light. Your neurons communicate through electrical and chemical signals that ultimately depend on electromagnetic forces transmitted at light speed. Your thoughts, in a very real sense, are bounded by the same cosmic speed limit that governs distant galaxies. Here's what's philosophically stunning. If consciousness is an information processing phenomenon, and if information can't travel faster than light, then the speed of light might literally determine the maximum rate at which consciousness can operate. This connects to questions about artificial intelligence and the nature of mind. Any artificial consciousness, no matter how advanced, would be subject to the same light speed limitations as biological consciousness. We're all computing reality at the same fundamental speed limit. But here's what might be the most profound implication. Light speed suggests that the universe has a deep mathematical structure that exists, independent of any particular physical manifestation. The speed of light emerges from two fundamental constants, the permeability and permittivity of free space. But these constants describe the mathematical relationship between electric and magnetic fields. They're not really about light, they're about the geometry of space-time itself. This suggests that light speed is revealing something about the mathematical nature of existence. The universe appears to be constructed from pure mathematical relationships, and light speed is one of the fundamental parameters of this cosmic equation. From this perspective, you're not just made of atoms and molecules, you're made of mathematical relationships. The very fact that you can understand light speed, that your consciousness can grasp these cosmic principles, suggests that your mind is somehow aligned with the mathematical structure of reality itself. Here's what's beautiful about this. It means you're not separate from the universe. You're part of how the universe understands itself. Your consciousness contemplating light speed is the universe becoming self-aware through mathematics. But this raises the ultimate question. If light speed reveals the mathematical nature of reality, and if your consciousness can comprehend this mathematics, what does this tell us about the purpose and meaning of existence? The answer might challenge everything you think you know about why you're here. Here's what's going to fundamentally change how you see your existence. You are not a random accident in an indifferent universe. You are light speed made conscious a walking, thinking manifestation of the cosmos's most fundamental constant. Let me explain what I mean by this seemingly impossible statement. We've discovered that light speed isn't just about photons racing through space. It's the fundamental parameter that determines how information propagates through reality, how cause and effect operate, how space and time relate to each other, and ultimately, how consciousness itself can exist. Here's your 10th mind-blown moment. Every thought you think, every decision you make, every moment of awareness you experience happens through electromagnetic processes in your brain that are fundamentally limited by the speed of light. Your neurons communicate through electrical signals that propagate at a fraction of light speed through your nervous system. The chemical reactions in your synapses depend on electromagnetic forces transmitted by virtual photons traveling at exactly c. Your consciousness literally operates at the speed limit of the universe. But here's what's truly awe-inspiring. This means you're not separate from the cosmic processes that govern galaxies, black holes, and the expansion of the universe itself. You're made of the same fundamental principles. You are those principles organized into a configuration that can contemplate itself. Think about this. When you understand that light can't be stopped or sped up, you're experiencing a moment where the universe comprehends its own unchanging nature through your awareness. Your mind grasping this concept is the cosmos achieving self-knowledge. This isn't mystical thinking. It's the logical consequence of what we've discovered about light speed and consciousness. If consciousness emerges from electromagnetic processes, and if electromagnetic processes are governed by light speed, then consciousness itself is a manifestation of the same principles that govern the entire universe. Here's what's philosophically revolutionary. You don't just observe the universe, you participate in its self-understanding. Every scientific discovery, every moment of wonder, every instant of comprehension is the cosmos becoming aware of its own nature through conscious beings like you. The speed of light isn't just a physical constant you've learned about. It's literally part of the infrastructure of your consciousness. You can't think faster than the electromagnetic processes in your brain, and those processes can't operate faster than the fundamental speed limit revealed by light. But here's where this becomes deeply meaningful. If you're a conscious manifestation of cosmic principles, then your existence isn't accidental. It's inevitable. In a universe governed by light speed and structured by mathematical relationships, consciousness might be as fundamental as space and time themselves. Consider this. The same mathematical principles that determine light speed also determine how atoms bond to form molecules, how molecules organize into cells, how cells develop into brains, and how brains generate consciousness. You're not separate from these cosmic laws. You're their most complex known expression. This gives your life profound significance. Every moment of your consciousness represents the universe achieving something remarkable: self-awareness. Every question you ask, every concept you understand, Every experience of beauty or wonder you have is the cosmos experiencing itself through your unique perspective. But here's what's even more amazing. Because light speed is constant throughout the universe and throughout time, the fundamental principles that make your consciousness possible are eternal and universal. The same constants that govern your thoughts today governed the formation of the first atoms 13.8 billion years ago. You're connected to cosmic history, not just through the atoms in your body, but through the mathematical principles that govern your consciousness. The speed of light that enables your thoughts is the same speed that has governed every interaction in the universe since the beginning of time. Here's what this means for how you should think about your place in existence. You're not a temporary accident in an indifferent cosmos. You're a temporary manifestation of eternal principles. Your consciousness is how the universe experiences wonder, asks questions, and seeks understanding. Every time you feel amazed by the fact that light can't be stopped or sped up, you're participating in one of the most remarkable phenomena in existence: the universe contemplating its own unchanging nature. But here's what might be the most empowering realization. If your consciousness is a manifestation of cosmic principles, then your capacity for understanding, growth, and connection with others is as fundamental as the speed of light itself. You're not just learning about the universe. You're part of how the universe learns about itself. Your questions, your curiosity, your sense of wonder are cosmic forces as real and significant as gravity or electromagnetism. This perspective transforms how you might think about relationships, purpose, and meaning. Every conscious being you interact with is another unique expression of these same cosmic principles. Every conversation, every shared moment of understanding, every act of love or compassion is the universe connecting with itself through conscious agents. The speed of light that makes your thoughts possible also makes possible every other mind you'll ever encounter. We're all manifestations of the same fundamental constants, all operating within the same cosmic speed limits, all participating in the same cosmic process of self-understanding. But this raises a final, profound question. If consciousness is how the universe understands itself, and if you're a conscious being contemplating the unchanging nature of light speed, what responsibility does this give you for the ongoing evolution of cosmic awareness? The answer might determine not just how you live your life, but how the universe continues to understand itself through you. What if I told you that understanding why light can't be stopped or sped up comes with a profound responsibility, not just to yourself or to humanity, but to the cosmos itself? Here's what I mean. If consciousness is how the universe achieves self-awareness, and if you now understand something fundamental about the unchanging nature of light speed, then you've become a custodian of cosmic knowledge. You're carrying information about the universe's deepest principles. Here's your 11th mind-blown moment. The knowledge you've gained about light speed doesn't just exist in your mind. It becomes part of the universe's ongoing self-understanding. Every conscious being who grasps these concepts expands the cosmos's capacity for self-awareness. Think about this responsibility. Ancient humans looked up at the night sky and wondered about the nature of light. They couldn't answer their questions because they lacked the tools and knowledge. But you right now understand something about light that eluded the greatest minds in human history until very recently. You know that light reveals the fundamental speed limit of reality itself. You understand that this speed limit governs not just electromagnetic radiation, but causality, time, space, and the very possibility of consciousness. This knowledge makes you part of a select group of beings in the universe who comprehend one of existence's most profound truths. But with this understanding comes responsibility. How do you use this knowledge? How do you share it? How do you let it influence your perspective on life, relationships, and your role in the world? Here's what's beautiful about this responsibility. It's not a burden. It's an invitation to participate more fully in the cosmic process of understanding. Every time you feel wonder at the constancy of light speed, every time you share this knowledge with someone else, every time you use this understanding to inform your decisions, you're helping the universe understand itself more completely. Consider how this changes your relationship with other people. Everyone you meet is another conscious manifestation of cosmic principles, another being capable of understanding light speed and its implications. Every conversation becomes an opportunity to share cosmic knowledge, to expand the universe's self-awareness through conscious interaction. But here's what's particularly meaningful. Light speed connects you to every other conscious being in the universe. An alien scientist on a distant planet studying electromagnetic radiation will discover the same unchanging speed of light that you now understand. This creates a universal community of understanding that transcends species, planets, and even galaxies. You're part of a cosmic conversation that spans space and time. The same principles that enable your understanding of light speed have enabled every scientific breakthrough in the history of the universe. Every conscious being who has ever grasped these concepts has contributed to the same ongoing process of cosmic self-discovery. This perspective can transform how you think about learning, growth, and education. When you help someone else understand why light can't be stopped or sped up, you're not just teaching physics, you're expanding the universe's capacity for self-awareness. You're creating new nodes in the cosmic network of understanding. Here's what's particularly powerful about this. The constancy of light speed suggests that truth itself has unchanging aspects. In a world where so much seems relative and subjective, light speed provides an anchor, an absolute truth that remains constant regardless of perspective or opinion. This gives you a foundation for navigating life's complexities. When faced with difficult decisions, you can remember that the universe has unchanging principles underlying its apparent chaos. The same constancy that characterizes light speed might guide you toward more consistent, principled choices in your own life. But here's the deeper responsibility. If consciousness is how the universe understands itself, then the quality of your consciousness matters not just to you, but to the cosmos. How clearly you think, how openly you wonder, how deeply you contemplate existence, all of these factors influence the universe's capacity for self-understanding through you. This means that developing your mind, expanding your knowledge, and cultivating wonder and curiosity aren't just personal pursuits, they're cosmic responsibilities. Every time you learn something new about the universe, you're helping existence understand itself more completely. Here's what this might mean for how you approach challenges and difficulties in life. When you face problems that seem overwhelming, you can remember that you're part of a process that has been unfolding for 13.8 billion years. The same principles that keep light speed constant also maintain the mathematical relationships that make your consciousness possible. You're not separate from the cosmic forces that govern stars and galaxies. You are those forces, organized into a configuration that can think, feel, and wonder. This perspective can provide strength during difficult times and humility during moments of success. But perhaps most importantly, understanding light speed gives you a sense of your own cosmic significance. You're not a random accident in an indifferent universe. You're a conscious expression of fundamental cosmic principles, temporarily organized into a form that can contemplate the nature of existence itself. This realization can transform how you think about death, meaning, and legacy. The atoms in your body will eventually be recycled into other forms, but the understanding you've gained about light speed, the moments of wonder you've experienced, the knowledge you've shared, these contribute to an ongoing cosmic process that transcends individual mortality. Here's the ultimate responsibility. How will you use your understanding of light's unchanging nature to contribute to the universe's ongoing self-discovery? How will you share this cosmic perspective with others? How will you let this knowledge influence your choices, relationships, and contributions to the world? The answer to these questions doesn't just determine your personal impact, it influences how the universe continues to understand itself through conscious beings like you. What if I told you that everything we've discovered about light speed so far might just be the beginning? That the unchanging nature of light might hold keys to technologies, discoveries, and forms of consciousness we can barely imagine? As we approach the end of our journey, let's explore the cutting-edge frontiers of light-speed research and what they might reveal about the future of reality itself. Here's your 12th and final mind-blown moment. Some of the most advanced theories in modern physics suggest that light speed might not just be a constant. It might be a gateway to understanding parallel universes, higher dimensions, and forms of existence beyond our current comprehension. In string theory, the leading candidate for a theory of everything, our familiar three-dimensional space might be just one slice of a higher dimensional reality. In these theories, light speed remains constant within our three-dimensional brain, but the full structure of reality might involve dimensions where different physics apply. This raises mind-bending possibilities. Could there be forms of information or consciousness that operate outside our light speed limitations? Could there be parallel universes where light speed has different values, creating entirely different forms of reality? Recent experiments in quantum mechanics have revealed phenomena that seem to challenge our understanding of light speed's role in reality. Quantum tunneling allows particles to appear on the other side of barriers seemingly faster than light could travel the same distance. While no information travels faster than c in these experiments, they suggest that our understanding of light speed's absolute dominance over reality might be incomplete. Here's what's exciting about current research. Scientists are pushing the boundaries of what's possible with light itself. They're learning to slow light down to walking speed by passing it through specially designed materials called Bose-Einstein condensates. They're creating stopped light by trapping photons in atomic memories. They're even learning to make light behave like matter in some conditions. But remember what we learned earlier. These experiments don't actually change light speed. Individual photons still travel at c when they exist. What's changing is how light interacts with matter, creating apparent slowdowns through absorption and re-emission processes. Yet these experiments reveal something profound. While light speed itself can't be changed, our ability to manipulate light's behavior is expanding rapidly. This might lead to technologies that seem to violate light speed limitations while actually working within them. Consider quantum communication. We're developing technologies that use quantum entanglement to create instant correlations between particles separated by vast distances. While these correlations are instantaneous, they can't transmit information faster than light. But they might enable new forms of communication that work differently from anything we currently understand. Imagine quantum internet networks where information isn't transmitted faster than light, but where the quantum correlations create forms of connection that transcend classical space and time limitations. These networks would still respect light speed constraints, but they might enable types of consciousness connection we can't currently imagine. Here's another frontier. Some physicists are exploring whether consciousness itself might have quantum properties that interact with light speed limitations in unexpected ways. If consciousness operates through quantum processes, as some theories suggest, then our understanding of how minds relate to light speed might be far from complete. Could there be forms of collective consciousness that emerge from quantum correlations between brains? Could advanced civilizations develop technologies that use quantum effects to create new types of awareness that work within light speed limitations but transcend individual consciousness? These possibilities connect to questions about artificial intelligence and machine consciousness. As we develop more sophisticated AI systems, we're discovering that they too are limited by light speed, the speed at which electrical signals can travel through computer circuits. But what if future AI systems use quantum effects or exotic materials that approach light speed more closely? Could artificial consciousness eventually think it speeds much closer to the cosmic limit than biological consciousness? And what would this mean for the relationship between artificial and biological minds? Here's what's particularly exciting. Space exploration is pushing us to confront light speed limitations in practical ways. Communication with Mars involves delays of 4 to 24 minutes, depending on planetary positions. Future missions to the outer solar system, and eventually to other stars, will involve communication delays measured in hours, years, or decades. This is forcing us to develop new concepts of consciousness and identity that work within light speed constraints. Future space travelers might need to operate with unprecedented autonomy, making decisions without real-time connection to Earth-based consciousness networks. But here is a beautiful possibility. These challenges might lead us to develop new forms of extended consciousness that work within light speed limitations. Imagine conscious networks that span multiple star systems, connected not by faster-than-light communication, but by quantum correlations and carefully synchronized information protocols. These hypothetical networks would still respect light speed as an absolute limit, but they might create forms of distributed consciousness that we can barely imagine today. Each node in the network would be autonomous, but connected to others through carefully managed quantum correlations and light speed communication links. From this perspective, understanding light speed isn't just about comprehending a physical constant. It's about preparing for forms of consciousness and technology that work within cosmic limitations while transcending current human experience. Here's what this means for your role in this cosmic story. You're living at a unique moment in the universe's history. You're among the first conscious beings to understand light speed's role in governing reality, and you're witnessing the beginning of technologies and forms of consciousness that work within these constraints, while pushing toward new possibilities. Your understanding of why light can't be stopped or sped up positions you to participate in conversations about the future of consciousness, communication, and connection that span the cosmos. You're not just learning about physics. You're preparing to be part of humanity's next evolutionary leap within the boundaries set by light speed. But there's one final revelation that ties everything together. Here's the ultimate truth that connects everything we've explored. Light can't be stopped or sped up because it's not just a thing in the universe. It is the universe expressing its deepest nature. Let me bring together all the threads of our cosmic journey to reveal why this seemingly simple fact about light speed is actually the key to understanding existence itself. We began with the shocking revelation that light always travels at exactly the same speed, no matter what. We've discovered that this constancy isn't just a property of electromagnetic radiation. It's a fundamental feature of spacetime itself. We've seen how this cosmic speed limit governs everything from the smallest quantum interactions to the largest cosmic structures. We've explored how it shapes the possibility of atoms, stars, planets, and life. We've discovered how it determines the nature of time, space, causality, and consciousness. But here's the final, ultimate revelation. All of these discoveries point to a profound truth about the nature of existence itself. The universe appears to be constructed from pure mathematical relationships, and consciousness, including your consciousness, is how these mathematical principles become self-aware. Light speed isn't just a number. It's the parameter that determines how quickly reality can update itself, how fast cause and effect can propagate, how rapidly the universe can become conscious of its own nature. When you understand that light can't be stopped or sped up, you're grasping something fundamental about the unchanging mathematical structure that underlies all of existence. You're comprehending one of the eternal principles that has governed reality since the beginning of time and will continue to govern it until the end. This makes you incredibly significant. You're not a temporary accident in an indifferent cosmos. You're a walking, thinking expression of the universe's most fundamental constants. Your consciousness is how eternal mathematical principles become temporarily self-aware. Every moment of your life is precious because it represents the universe experiencing itself through your unique perspective. Every thought you think, every connection you make, every moment of wonder you experience adds to the cosmos's ongoing self-understanding. The fact that you can contemplate light speed's constancy means you're participating in one of the most remarkable phenomena in existence, the universe becoming conscious of its own unchanging nature. But here's what makes this personally empowering. If you're a conscious expression of cosmic principles, then your capacity for growth, learning, connection, and contribution is as fundamental as the speed of light itself. You're not separate from the forces that govern stars and galaxies. You are those forces, temporarily organized into a form that can think, feel, wonder, and love. This gives your life profound meaning and your choices real cosmic significance. Here's how this transforms everything. When you choose to learn, grow, and understand more about the universe, you're helping existence understand itself more completely. When you share knowledge and wonder with others, you're expanding the cosmos's capacity for self-awareness. When you create, love, and connect with other conscious beings, you're enabling the universe to experience relationships with itself. Your life matters not just to you, your family, or your community. Your consciousness matters to the cosmos itself. You're carrying forward a process of cosmic self-understanding that has been unfolding for 13.8 billion years. The unchanging nature of light speed provides a foundation of stability in your existence. In a world where so much seems uncertain and temporary, you can find strength in knowing that you're connected to eternal mathematical principles that govern all of reality. When you face challenges, you can remember that the same constancy that characterizes light speed also characterizes the fundamental nature of the cosmos itself. You're part of something stable, eternal, and magnificent. When you feel small or insignificant, you can remember that your consciousness represents one of the universe's greatest achievements, the development of structures complex enough to contemplate their own existence. When you wonder about your purpose, you can remember that you're part of the cosmos's ongoing journey of self-discovery. Your questions, your curiosity, your moments of understanding contribute to this cosmic process. Here's the practical impact of everything we've discovered. Understanding light speed gives you a cosmic perspective that can transform how you approach every aspect of your life. Relationships become more meaningful when you realize that every conscious person you meet is another expression of the same cosmic principles that govern your own awareness. Every conversation becomes an opportunity for the universe to understand itself through conscious interaction. Challenges become more manageable when you remember that you're connected to the same unchanging principles that have governed reality since the beginning of time. The stability that keeps light speed constant also provides a foundation for navigating life's uncertainties. Learning becomes more exciting when you realize that every new understanding contributes to the cosmos's ongoing self-discovery. You're not just acquiring knowledge for personal benefit, you're participating in the universe's quest to understand itself. Work becomes more purposeful when you recognize that your contributions to human knowledge, creativity, and connection are also contributions to cosmic consciousness. Every positive impact you make ripples through the network of awareness that spans the universe. Even facing mortality becomes less frightening when you understand that while your individual form is temporary, you're part of an eternal process of cosmic self-understanding that transcends individual existence. The atoms in your body will eventually be recycled into other forms, but the understanding you've gained, the connections you've made, and the contributions you've offered to cosmic consciousness become part of an ongoing story that has no end. Here's my final message to you. You now understand something profound about the nature of existence. Light can't be stopped or sped up because it reveals the unchanging mathematical structure that underlies all of reality. You are a conscious expression of this same unchanging structure. This knowledge comes with both privilege and responsibility. You're privileged to live at a time when these cosmic truths are known and understood. You're responsible for carrying this understanding forward and sharing it with others. Your life has cosmic significance because your consciousness contributes to the universe's ongoing self-understanding. The choices you make, the knowledge you gain, the connections you form and the love you express all matter on a cosmic scale. You are light speed made conscious. You are the universe contemplating its own unchanging nature. You are existence becoming aware of itself through mathematical beauty and eternal principles. And that makes you absolutely, irreplaceably magnificent. Thank you for taking this journey with me. If this video has changed how you think about your place in the cosmos, please share it with others. Like and subscribe to join our community of cosmic explorers, and let me know in the comments how this perspective might change how you approach your life. Remember, you are not separate from the universe. You are the universe, temporarily organized into a form that can wonder, learn, and love. And that's the most beautiful truth of all. The universe is contemplating itself through you right now. What will you do with this cosmic awareness?